Good morning. I almost want to say good night because it's still pitch black outside. Welcome back to week 8. As I was kind of saying earlier, I can't believe it's already week 8. There are literally 4 weeks left to cover characters and the entire rest of environment art, which is looking like after today there'll be shaders to cover, lighting to cover, and then rendering and portfolio stuff to cover. So that's 3 weeks right there. Maybe one more week. So definitely that character stuff is going to be pushed to Superior. I talked to him about it, so we are going to kind of split courses here. So Superior will be handling the character stuff. The next one will be about creating base meshes as a kind of principled thing. So it's not going to be using Blender, I don't think. I think he's going to use ZBrush, but the ideas remain the same. How to block out characters, how to get anatomy kind of correct, and then go from there. And then I'll teach you about retopo, subdiv, and multi-res workflows so you can actually sculpt detailed characters and things like that. And then finally, I think the last one for him would be retopology and creating that high detail mesh that you can use to animate and all that kind of stuff. So we are going to split off a little bit here just so we can cover a little bit more content. And I think confidently we can get through all of the stuff that we need to do in environments if we just have that lecture time. The one exception is I think this week, Superior is going to stay in this realm because you are going to need definitely more time in Substance Designer since this is a program that you literally never used before. But it's super useful, I promise. You're going to get a ton of use out of it. There are no slides. I did ask you to come to class with it already installed, so hopefully you kind of already did that. And we can just jump right in. But first I'll kind of talk about what Substance Designer is and why we need it. So generally speaking, when we're creating textures for our environment, there are a lot of objects that we can get away with texturing individually. As we kind of know, that's the default workflow. You're all very familiar with just texturing something one-to-one. Welcome. On top of that, we've now learned about these additional workflows of using trim sheets and creating modular assets. So that's another way that we can go about doing this kind of thing. And these methods are great for creating details for objects that tile in one direction, right? So we're trying to maintain our textile density and level of detail in one repeating direction on our UV set. But when an object needs to be textured and it's too big to tile in one direction, we need to create tiling textures that allow us to tile in both directions. So anywhere in the scene where you think that's going to be happening, typically we're going to lean to Substance Designer or creating tiling textures from images or some other system like that, or in some extreme cases, even painting our own custom textures. Now, the good thing about these textures is you already know how they work. The reason I was comfortable with not doing any slides this week, you understand base color maps, you understand normal maps, you understand metalness maps, and you understand the idea of building up masks layer by layer to create these black and white images that control where our detail is. That is not changing. All the stuff that we learned in Substance Painter, all of that is built on Substance Designer nodes. That cool stuff that you have in there, like the high pass filter, the blur filter, it's actually all built in Substance Designer, and then that node is passed into Substance Painter as some kind of either math function or other node. Okay, so we're kind of coming back to the root now. We started with the higher level stuff, and now we're moving down to the lower level stuff. So where this is useful is anywhere you're going to see some kind of repeating detail that we can replicate. So areas like floors, walls, giant tiling carpets, right? If I look at the checkered pattern on the ground here, this is a great area where we can use Substance Designer. If we're creating brick walls that cover an entire large outside environment kit, other floors, etc., 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 Substance Designer, these tiling textures, they're going to be the way to go. Right. I'm going to show a few examples of materials created with Substance Designer to show you just the absolute range of things you can make with it. Because it's not limited to just these tiling textures. You can go as far as creating books as a tiling texture. One recently that came out was ladybugs moving. This was recently revealed by Javier Perez at Substance Day. And this is also, just like everything else, a tiling material made in Substance Designer. So the limits of this are basically endless as long as you understand those core principles behind the Substance Painter stuff we talked about, understand your base color, your metalness, your height, AO, etc., etc., etc. It's lagging a little bit, but you get the idea. Okay, these things are all made up of nodes. So how many of you are familiar with Unreal Shader Graph or Unity Shader Graph? Mostly, for the most part. So we're doing a lot of the same stuff that we do in there, but here we're doing it procedurally with just a different set of nodes. So hopefully you already have it installed. You can just pop it open here. And we'll get started, and I'll introduce you to the UI and everything like that. Now, this is an intro, and unfortunately we don't really have time to do multiple classes on this if we want to get all the environment stuff done. That said, there is an assignment on this. So you are going to have to do a little bit of self-exploration here when it comes to really diving into what you can do with Designer. I'll give you all the fundamentals and basics you need to get started, and then you'll have to kind of look at extra resources to complete the assignment to some reasonable extent. Okay? You're going to have to do this anyway, though, because every single one of your environments will need some form of tiling texture in one way or another. So it shouldn't be extra work because you're needing it for the final project anyway. Okay. This guy, Dana Tyre, is the probably just leading guy in Substance Designer. He's been doing it forever. And whenever people need more information on the program, they go to him. So you can look at his examples as a reference, but we're creating all of these same maps for PBR, and you can see them reflected in the material here. We have two main benefits to using this over creating textures from images like you did in Super's lab, and that is, one, because they're procedural, you can actually change them after the fact. So if I decide that instead of I want these to be 4x4 tiles crisscrossing the way they are, you can make them 3x3 with a single change of a number, and everything else stays the same. Okay. Here he's showing off the height map and the normal map put together to give you an idea, and then the material itself, right? Another one, something that might be useful for your game, some kind of broken concrete, right? Maybe you have a clean concrete and a broken concrete, and then using what we call vertex blending, which we're going to start learning about next week, we can blend the two different materials together to create some patches of broken up concrete and some patches of clean concrete, right? And this is all just boiling down to height map, normal map, base color map, etc. And the last example I have here is something a little bit more stylized. You can kind of see the process that we're going to be looking for and follow. We want to build up big to small shapes, and then big to small details, one map at a time, usually starting with the height map just to get a better idea. Okay. If you enjoy this kind of thing, I will say now as well, really dive deep into it. This is a whole job in and of itself. So material artists are a legitimate job in industry where all they do is work in Substance Designer, creating these tileable textures. Then they either pass these tileable textures off to be used in one-to-one modeling or texturing, or they pass them off to be used right in engine in these grand environments. So this is a legitimate job, legitimate profession. If you enjoy this process at all, I would recommend to really dive deep into it. You can make really good money doing this. Last for the assignment, because this always happens. There is a 10-minute long video just covering how to submit these things. As you can see, these graphs get pretty complex, they get pretty big. If you just submit me a screenshot, I'm literally not going to be able to read it. So this video is 10 minutes long, that's it, and it just goes over how to create your renders of your material. Really quick and easy, so you're not taking screenshots. And also how to submit your graph itself in a way that I can actually make out the nodes and read them. So that's it for the material assignment. Like I said, you'll have to explore a little bit on your own. If you want to, I'm okay with using YouTube resources to learn the stuff, right? I'm not expecting you to just like read documentation and somehow come up with all this stuff. YouTube tutorials are available. If you're going to use them, just make sure you link the tutorials in your submission as well, okay? So that would be part of your reference and process mark there. So while we're going through this today, I'd also recommend you think about the material and maybe throw it by me, because a lot of people get really inspired when they start to learn this stuff and they go, okay, I'm gonna make ice. Ice is not something you can really make with this very easily unless you've been doing it for 10 plus years. So maybe run your ideas by me first so that we can get a good grasp on whether or not it's feasible. So with that out of the way, this is Substance Designer. This is the program itself. I'm going to start by just kind of pointing everything out to you. Does your screen look something like this? I honestly don't know what it looks like anymore. The default, it probably looks different. My version is 2021, so it's 4 years out of date because I don't feel like paying for 2025. So yours is probably going to look a little bit different, but I will take my time with telling you where all the different things are so that hopefully you can find them. So just like Substance Painter, this was built by Algorithmic, pretty sure, before it was bought by Adobe. So the programs mostly function the same as far as the UI and everything, which means you should be quite familiar. To get started, I'm going to take you up to File, New. I have a few different types. The only one you really need to worry about are Substance Graph or Substance Function Graph. So Substance Function Graph is going to allow us to create our own new nodes. You have to be good at math, just straight up, I'll be honest with you. If you're going to use any of this stuff and create your own nodes, it's literally just raw math. Otherwise, Substance Graph is the only one you need to worry about. So I'm just going to hit Substance Graph, and we'll pop up with a bunch of stuff we should be pretty familiar with by now, right? You've probably seen a lot of this in Substance Painter. We've got different presets for all kinds of different PBR maps. Kind of controversially though, I'm going to recommend you press empty here because I want to show you the process of actually building up the export and showing you how flexible it is for each different project. So I'm going to press empty, which means our scene is going to start with absolutely nothing in it, and we can name our material something. I think I'm going to make bricks just because it goes over a lot of the good concepts. So bricks is what I'm going to make. Okay. Just like in Substance Designer, we need to set some kind of native resolution for our textures. Typically, depending on your project, these are going to match your textile density targets. So if your textile density target is 512 pixels per meter, you probably want to make these at 512. If it's 1024 pixels per meter, you're probably going to want to make them at 1024, or make them a size bigger and then downscale them when you put them in engine, which is typically looks a little bit better than making them smaller and then blowing them up. Caveat, because we are working on a node-based system here, every node has to compute before it can render our output. This means from jumping from 1024 to 2048, we're not just increasing the memory usage by 4. We're also increasing the processing time by like an astronomical amount because it's going to increase each single node's rendering time by 4. So if you have 3,000 nodes, it's going to take 12,000 nodes worth once you bump it up one. Okay, this is a rough approximation because some nodes aren't as heavy as others, but generally speaking, keep it low when you start. Okay, so let's press OK, and we'll jump into a new file. Like Substance Painter, a lot of it's handled in this Properties tab over here, and it's a little bit easier to understand because unlike Substance Painter, there's no weird second and third panels or texture sets or mesh sets. We're going to create all that ourselves. We have a viewer down here that we can move around very simply just by left clicking. You can zoom in and out by right clicking. That's all you really need, right? And then it's middle mouse to pan around. So we have both the 3D view and the 2D view, and then our asset library here. To actually see anything starting up on our mesh here though, I'm going to right click and a menu comes up that says add node, add comment, add frame. These are the big three you're going to be using. The nodes, we'll have to learn one by one what each of them do. The comments and frames are pretty self-explanatory, but they're to keep our graph organized. So the first node I need to introduce to you is the base material node. You can add it by right clicking and going to add node, or you can hit spacebar and you can Google nodes by name. So for now, you might want to right click because it shows you and has all the names for a lot of the different nodes. You can also find them up here at the top. So if we find base material, it's not one of these ones actually, so we will have to type it in. Okay. And then down here we find base material. So this node here is going to get us started. You can pretend this is a very simple base material in Unity as well as Unreal. It has a bunch of different properties that you should be well familiar with by now. Base color, metallic, roughness, height. And by default, it doesn't allow for any inputs. This gives us a good base because we can quickly change any of these values to get a better idea of our material. Okay, if I change this to red right now though, you'll see it's not actually affecting our object. We're gonna have to right click on our node and drag. Any node that you right click and drag into your viewport will preview it in the viewport. So I can take this node, I'm still holding right click, and if I let go on my object, it will inherit this node. So now any changes I make are reflected in the node. Okay, you only need to link it up once, and then it stays linked. This node is also where we're going to start the export for all of our future nodes. You'll see at the back here on the right is exporting. If you're familiar with any node system, this is the same thing. We have base color, normal, roughness, metallic, height, and ambient occlusion. But by default, these aren't actually going to export anywhere. We have to tell the program, hey, this is what I want to export. The reason for this is because we can do a lot of different things. We can channel pack different things together. So we could take the roughness, metallic, and ambient occlusion, for example, and smash them all together in what's called an RMAO mask. For now, we'll just do one-to-one to keep things simple. So I'm going to grab base color, left click, and just drag out somewhere. And when I let go of a node, it will automatically bring up a menu where I can find a node that I'm looking for. So in this case, we're looking for output nodes. So if I just scroll down, I can find output right here. Okay. All this output node is doing is telling the program, hey, whatever is in here, I should export to a texture when we export things. So you can see it shows up here in my package underneath my bricks graph. I now have output with no description. For the identifier, this is just the name of the node here. We can change this to base color or diffuse or just color, whatever you'd really like. And then I'll take this down and I'll just copy and paste it in label as well. Okay, we'll refresh the node and now it's labeled base color. The last two things that you want to do for your outputs are specify what kind of texture we're exporting. You can leave the format as default, but then down here for usage, we're going to tell Substance, okay, the red, green, blue, and alpha channel, we're going to use all of these for our diffuse. So diffuse, as we know, is the same as base color. You can jump between the two, but if you leave it at the default of diffuse, when you use tools like exporting this texture to Substance Painter, it will understand where to put the different textures. Okay, and then last, you can specify the color space, not necessarily super important, but for a base color, it would be sRGB. Okay, and we can repeat this by hitting Control-D to duplicate. So Control-D, pretty standard for duplicating anything in any program. And now we're going to drag the normal in, and we're more or less going to do the same thing. So find the usage, in this case this is the normal. I'll change the identifier to normal and the label to normal. Okay, so this is just a series of textures we're exporting. I'm going to go ahead and do this for all of them. So roughness, output, scroll down to usage, find the roughness, and then label this roughness. Caps, no caps, it doesn't really matter. You can call them in the label here, whatever you really particularly like. That doesn't matter. So this one is for metallic. Same thing, find metallic. Label it metallic. So in getting you to think about all of these as individual textures, hopefully you'll understand a bit more of the process when we get to working on these one by one. So next, same thing, but this one's for height, 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 height. Finally, ambient occlusion. Okay. So that's all my outputs out of the way. I should have mentioned I was scrolling around like this with middle mouse click, if you hadn't caught that on already. Middle mouse to scroll around. We have now a base material with a bunch of different exports that are all shown here. And we know that they will export because they show up here in our graphs export panel. So far, so good. We want to work on things one channel at a time. And typically we're going to start with the height map. So the height map is something that's not all that familiar to you as it stands now. It's not something you would have used very much. We aren't necessarily building this height map for the sake of using it in Engine. We're building this height map because all other data forms that we're going to find, be it normals or anything else, is going to start with this height map. You can imagine if I have a tiling material that's, I don't know, a checker pattern, but every other tile is metallic. The easiest way to mask out those metallic ones is going to be by grabbing their sections in the height map because they're going to have some large values that we can use. So we're always going to start with the height map. What this means for our base material here is we can use this as a proxy for all of the other channels while we work on the height map without having to worry about them. So what do I mean by that? Well, this base material lets us open up inputs for all the rest of our material outputs. If you scroll down here in our base material to user-defined maps, you can see we have a bunch of true or false flags for using our own maps. But right now, we don't actually have any of our own maps going into things, so you can see the material just breaks. Obviously, if the material is broken while we're working on it, we're not going to be seeing much, and this isn't going to be super useful to us. So instead, we can work one channel at a time here. All right, and if we start with just height, we won't break the material, and we can quickly do some look dev by switching the color, changing the metallic, doing anything else in here, right? So I can change the metallic to 0. I can make it glossier. I can make it rougher. And the material is not breaking. So I can get a good idea of how good my height map is before moving on to the next map. So now we want to think about actually building up our first height map. We're going to work big to small, just like anything else. And there are a bunch of existing resources that you are probably quite familiar with. You might recognize all of these noises from Substance Painter. These noises actually originate here in Designer. You can see by this little graph symbol that there is a graph inside of here that they use to actually build this noise. And that goes for basically all of the noises available. Under patterns, we have a similar situation. And we have a bunch of different things that we can use to get started. So for building things like checkered tiles or bricks, we can usually find something to get started with and then adjust more to our liking. So think of these as kind of those base materials. if you see this little symbol, it means it has properties that you can use to adjust it. So in this case, one of the properties is tiling. So I could take this down. And one of the properties is rotating at 45 degrees. Right? So I could have something like this or something like this, all very quickly. Let's get an idea of what the height map does. I'll just grab one of these textures and slap it on. So just like any other node-based program, we can take our node and just drag it into our input for height. And by default, you kind of see things going on, but you don't really see much. It kind of just looks like it's affecting the normal map. Here, we can go to materials in our viewport. And you're gonna have to do this every time you open your project, so I'd probably pay attention to this. Materials, default, and then within the default, we're gonna find tessellation or displacement or parallax occlusion. You're gonna wanna press on tessellation or displacement because that's what we're using in our viewport. And then once you've done that, it will,
I'm not seeing that in materials. Went to materials default and
it is now different. Okay. How do we find this panel then? It would be, there should be another way to get to it.
Sorry, what was your process? It was materials, default.
Yeah, if you just, is there a materials default edit?
Yes, there is. Yes.
Okay, go to materials default edit instead then. It should bring up the same window here on the right. Okay, cool. So they must have just changed the rendering. It's still using OpenGL?
Yep.
Okay, perfect. So by default, yeah, this is built on OpenGL. And here we have a few different options for how our rendering is going to happen. But the only one we care about right now is down here. We're going to find height, and then we're going to find height scale. So if I increase height scale, let's say we bump it up to something like 7 here, you'll see the height map is actually physically moving the vertices of my mesh. Okay, this isn't faked detail like a normal map is. This is legit model detail. Those ladybugs from earlier, this is how they come to exist. It's just a subdivided circle with a bunch of vertices on it, and that ladybug is a height map. So here we have a lot of that height detail in our mesh, which is great. Okay, so we want to build these height maps up, not necessarily because we're going to use them in Engine, but because we can get a much stronger image for our material when we have a good height map built up. Height maps work pretty simply. In our rendering here, we have a height level and we have a height scale. So height level is going to be where your middle gray value lies. So these are black and white textures, meaning that 1 is going to be the highest point in your texture and black is the lowest point. This height level will just say, hey, 0.5 being neutral gray, that is the middle of my texture. So anything that's moving up to white from 0.5 is moving up an equal amount as from 0.5 to black. If I was to bump this up to 0.9, anything moving from 0.9 to 1 would be moving a tiny amount. Anything moving from 0.9 to 0 would be moving a lot more. Yes?
I don't see height scale in mine. Just height position, height range, that's it.
Those are similar things. Height position, I think, is the same as height level as far as I know. And height range is the same as height scale.
Yeah, maybe
Okay, that also would do it. So these settings are not just limited to this program. These are also in your engines. So if I was to create a height-based material in Unreal, I would have also control over my height scale and height level. This is just the renderer for this to give us a better idea. Okay.
Okay, thanks. Makes sense.
So I'll remove this now, and we'll get started with something else. I thought I was going to make bricks. I think I lied. I might as well make something from our scene. And there are two main huge candidates that we can kind of create here. One being this checkered floor pattern, and one being these large kind of roof truss-like shapes. Okay. We'll start with the checkered floor pattern and see where we go from there. this should take up a fair bit of time, and it will kind of go over all the intricate stuff. So we can have, by default, we've got a checker material that we can start with. So I'll just drag out this checker material. Obviously, this checker material that we make won't really help any of your projects unless you're also making the same thing I am. But hopefully it gives you an idea of when to use these things. So for now, I'm going to reduce the tiling a bunch. I want to just get very specific detail with what I've got. I'm going to rotate it 45 degrees because if you leave it flat like this and you were to slap it in your scene, a lot of these parallel lines will kind of guide the viewer as to where this pattern tiles a bunch. So if you're using a square pattern, sometimes it's better to have it go diagonal just so that the tiling isn't as obvious in your scene. I'm going to start with this, and I'm going to rotate it, and then we'll kind of start breaking it down into different things. The two first things I'm going to do is drag this out into what's called a levels node. So this levels node is your new best friend. You're going to be using it all the time because this is a great node for controlling all the black and white values in our materials, or our textures, sorry. This works the same way as the one in Photoshop, if you're familiar with that. We have 5 controls, being output and input black and white, and the middle gray value. So there's no gray here, so it's not going to do anything. At the bottom is our output values, meaning whatever final texture we have here. If we have this black one at 0, it will export a value of 0. But we can raise this up to say, hey, that should be somewhere up here, right? Now it's got a black value of around 0.3, so 0.3 is the lowest value that's going to be exported. Why is this useful? Well, I just talked about those height maps and how they work from a middle value out. So we want our starting values to be as close to the middle as possible on our height map to give us more range to work with later. If I leave these tiles as pure white and then later I go, actually, I want to put like some dirt on top of the tiles, I've got no more height space to work with to actually put that dirt on top of the tiles. So we want to start with less variation because we can always bring more in later. So we can bring this pretty close together here in the middle, right? And this is a much better starting height map than what we had there originally. We're building up the shapes as big as possible first, and then we'll shrink everything down. Another node you're going to need to get familiar with is creating normals from your height map. So we don't actually create separate normal maps. We're going to be using our height map. This is really similar to Substance Painter 2. If you're adding scratches or anything in Substance Painter like you have been, you're doing it in the height channel. And then, bless you, it's converting that to a normal map after, right? So this is the same thing. So we have our levels with our height map in it. We can use a normal, right? And here we have height to normal, okay? And this will attempt to create a normal map based on our height map. Now there is still a problem with this height to normal process, and the problem is our height map. Just like when we're modeling, how we need to have edges that catch light at angles and things like that, if we try to bake a height map into a normal map here, even in 2D, because these are sharp angles with no actual anything, our normal map is coming out with no actual real detail, right? It's just coming out basically flat. So we have to make sure we're adding bevels and things like that. There are a few different ways we could do this, but for now, let's just plug everything in to our base material. So now we can kind of see the height. And for this material, I'm going to change the view model here. So by default, we have this rounded cube. For a checker material like this, it doesn't make a lot of sense. So I'm going to switch this to a sphere, 2 tiles. So this is very simply a sphere with the texture tiling twice on it and a healthy amount of vertices for your height map. So let's pop back into our base material. And since we have this normal map, we might as well open up our normal and pop this in here as well. Okay. And we have something to kind of get started with. From here as well, we've got our normal. Now we're also going to create our ambient occlusion. So I'm going to pop this open, add another one, and this is going to be an HBAO node, which stands for height-based ambient occlusion. Yes?
What's the difference? Because there's two of them.
There's two of them.
There's
Ah,
talking about it, and I think it's
yeah. Ignore RTAO. Use HBAO. That's all you really need to know about that, to be honest. And then let's plug the ambient occlusion in here as well. So the ambient occlusion, the other reason we're doing this so early is because it will really start to separate our shapes and give us a much better idea of how we're looking over here on our height map. So let's open this up.
But
Yep.
You said ignore HBO or RTO.
Ignore RTAO.
Alright, thank you.
Use HBAO. So if I drag my ambient occlusion in here, now I'm really starting to see the separation in my tiles. Okay. I'm going to bump up the tiling on this once more. Maybe one more time even. And again, because this is procedural, it's great because we can change this at any time. This looks better to me. Yep.
Is there a way I can change my the resolution after I made the project?
Yep.
Because I made mine 512 and I want to change it so
There are two ways to do that. One is every node inherits the texture size from the previous node. So by default, the very first node is this 1024 L16. And you can see every node after that is sort of inheriting that. So 1024 and stays color 16. And then our exports also inherit that 16-bit. Which means if I change this very first one to 2048, oh, not that, don't go that big. If I change this first one to 2048, everything after it is going to inherit that 2048 detail. It's actually really good as well because sometimes you want a higher detail height map to just give you better information to pass on to the next ones, but you don't actually want these to be that 2048. You just want the extra information. You can cut this in half, and now every node afterwards will be 1024. But I still have the information from the 2K map. That's a little bit more advanced though. For now, you just need to know if you change the first one, everyone after will change. The other way is if you don't have any parent inheritance, up here you can just change the parent size, and that will change it for all of them because they all start from inheriting up here. Change it back to 1024. Okay. So we have a height map, we have an ambient occlusion map, and we have a normal map all plugged in. Now we can kind of take this height map off to the side and continue to work with it more and start to build up our shapes a little bit. So the first thing I probably want to do here is introduce some kind of grout. I'm going to move this levels a little bit further down in the line. We'll probably do some more black and white work here, creating our grout and things like that before we bring it into levels. So the first thing I'm going to do here is run an edge detect. A bunch of these you're going to have to just kind of work with until you figure out exactly what tools work for you. But this is going to create that tile-based effect. What it does is essentially goes between each one of these points, checks the pixels around it, and sees if there's a large difference in value. Right? So here we have this tolerance slider that helps with that. I'll leave it at 0, and we end up with the pattern we're kind of looking for, these soft rounded tiles with these little opportunities for diamond bits in the middle. And then we'll drag this into our levels. Now we're looking a little bit more like tiles. If we want to change the width of the grout here, we have options like edge width that allow us to make these tighter, and edge roundness, which allow us to change how round the actual corners of these tiles are. So we can give them a little bit of rounding and keep them pretty tight together. The other thing I want to run is a bevel. So we do have some modeling controls here as well, since this is for height maps. Bevel is one of the options. So if I hit bevel here, it's going to export both a normal map and a height map. I'm just looking to use the height map for now. But you can see it is going to bevel these edges as if they were all raised faces, right? So it's building off of our height map as an input. And where it sees a difference in height, it will bevel in off the edges. You can also use, this is just like the bevel node in Photoshop as well. It's all the same kind of system. So imagine this is just a big image editing software for tileable materials. You can see that everything we've done so far, it automatically will tile across an object, no questions asked. So these corners, I'm going to want to set them to round for sure. And I definitely want a little bit of smoothing on those corners as well, because I don't want these tiles to be super duper sharp at the edges. You can increase and decrease the distance bit by bit. And then we can drag this into our levels. And now you can see we have a much nicer blend between our bevel edges and our grout. So much better than we had before. So there's something else that we do all the time in Substance Painter that we need to learn how to do in Substance Designer, and that is masking out different areas. So there are a few different ways to do this. It's going to be a little bit awkward as well. But half of these tiles we want to be a certain color, and half of these tiles we want to be the opposite color. And we also want it to be procedural, so that if we make any changes to half the tiles, it happens to all of them every single time. If we change the number of tiles, it's going to happen to all of them every single time. So to do that, we can continue building off of our original texture, which by default works well for us because we have two different colors here. I'm going to run a levels again here. What you can do is actually flip the output and input channels. So if I bring this black slider all the way to 1, then all of my black values will have a minimum output of 1. If I slide the white to 0, all of my white values will have a minimum output of 0. So if I swap this, I end up with an exactly inverted version of my image. So now I can use these different masks. It might be easier to tell if I get rid of the rotation. But I can use these different masks because they're exactly inverted to say, hey, this tile should be white and this tile should be black later on in the process. So let's put that for there for now. I'll kind of move this all in closer. We can go back to our levels here to adjust it a bit more. We can see that this is quite steep. We probably don't want it to be out that much, our tiles. So we can reduce our range even further in the levels node to get them closer together. Great. Okay. Now I need to isolate half and half, but I also need to isolate the grout. I don't want to use this as a mask for this tile, because when we actually go about combining everything, that edge is where the grout's going to be. So this is where we start getting into using blend modes to control everything. So again, just like kind of how we built up our masks in Substance Painter, we're doing it with Designer procedurally. I have a bunch of blend modes available to us, including We just add in a blend node here, including our good old friend multiply. So we can actually take our checker material here, and then we can use some form of multiply or subtracting with our edge detect. And you can see it's cut out the grout from the tiles. So we still have the isolation in the tiles, but the grout has now been cut out. So if I double click the original node, and then the blend node, I still have half my tiles selected, but the grout is gone. And I can just duplicate this again for the other side of tiles, the other set. So blend again, we'll use multiply again, and I'll pop this in. Okay, and now I have the opposite inverted tiles, but without the grout. Yep,
Did you duplicate the blend levels?
I duplicated the blend. Yeah, so just one levels. This one levels is only here to invert, so I get the opposite tiles as a mask. And then this blend gets rid of the grout on one set of tiles. This blend gets rid of the grout on the other set of tiles. There is some nonsense I could do where I combine these into a final node to put into the next blend. But because in this particular case, this grout is the exact same thing, I can just run this edge of text straight into my next phase. So we're working up bit by bit, little by little here. I want the bevel to happen to all of the tiles, so I'm not worried about the bevel for each individual set. So we can leave it kind of like this. The tiles themselves aren't actually going to have any difference really between the sets other than the color. And maybe you might use these masks and do different roughness variations and things like that, so it doesn't look like the roughness is just continuing over all of the tiles together. But maybe that's something you want, you could combine them. For me, we're going to combine that, and I'm going to leave these only for color or other details. So let's take this now, and we'll just throw some kind of color into it. I'll just throw a gradient map on it, which turns it into color data. So this gradient map, which is the very first one, it will take your black and white map and map a new gradient to all the gray values. If I take a different node, this one's kind of hard to tell what's going on, but let's look at something like this one. If I drag this into a gradient map, what was this black and white gradient, we can change into color. And then we can actually go through and say, hey, this gradient now is red to blue. And so all the values that were at this end of the gradient, the black end, become red, and all the values that are on this end become blue. Very useful for getting a lot of good detailed texturing done. We'll explore it a little bit more later. This particular pattern, the checkered material, isn't going to make much use of it, so I thought I'd just introduce it there. We can also use it as something to just convert our black and white map to a color map. You'll notice as we've worked, we've had these yellow input dots and these gray input dots. The yellow input dots are going to require color information. So any yellow input dot is going to freak out for the most part if you just give it a grayscale. And vice versa, if you try to put a color into a black and white, it will freak out. There are exceptions. You'll see this one has a little hole in it. My understanding is that means this one could take either or. Nope, never mind, sorry, the hole's something else. Let me see if I drag the yellow one into here, it's just going to freak out. Let's drag this back in. And then recompute everything. There we go. So we'll take our gradient map here. We'll open up another new channel for base color. we can plop that in. And now we're starting to get our actual checkered material. There's still one issue, and that is we have this grout being the same as our other material here. That's why I kind of separated these, because it gives us the option to take our grout and use it as its own mask, where we can apply its own color. So I'm going to grab a node from my grout now and use a blend. And this is going to be what's called a single channel blend, where I'm just going to use this as an opacity mask and I'm going to blend in some new colors. So just like the gradient, we can also just add colors. So down here we have uniform color, which lets us create individual color nodes. It also works in black and white, but here we need color. I'll pick some value that's very obvious to start. We'll drag our grout into the opacity. And then we want to invert our grout here as well. If you click on any link between nodes and then add a new node, it will create that node in that link. So if I have this node already between edge detect and this blend, and I need to invert it, I can click the link, type invert, and it will automatically link up my new node. Okay. So my color here needs to go into the background. And I'll duplicate it, and this one doesn't really matter, but I'll just make it white or something. And now you can see we've created what we can use as a mask for our grout, and then added some color to that grout. So obviously I don't want this pink here. So I'm just going to use a value of pure white for the background, and then this red color will become the color for the grout, which we'll adjust later. Let's work on the actual tiles themselves. We need to create color versions of the tiles now, since it's all in black and white at the moment. So we can take our gradient map, do another blend, and we're just going to blend these two together basically, so that the grout comes out underneath. So let's pop into our modes here, and we can kind of snap down them until we find something that we're looking for. And we can flip. There we go. All right, so because these white areas are all white, in this blend I'm using the subtract blend mode, and it's going to cut all those areas out to show our underlying texture and leave the grout. All right, so it's flipping our tiles and showing our grout. We can drag this now into our base color. And we have that separate color for our grout. We want to build up all these masks now, because these masks are going to be super useful when we get to actually creating roughness and everything else. The red color, we can kind of ignore, it's red. We can always change it later. Yep, Aiden.
Between the edge detect and the blending added to the red, what pieces in the middle get at?
This is an invert. So the edge detect here what we actually want to mask out is this grout part.
Is it just called invert?
Yep. If you just invert, it'll come up with invert grayscale, and you'll get what you need. So we can add a dark color to this, and we end up with a dark color in our grout. So we have the base of a checkered tileable texture. And because of the way we've built it, it's all very procedural. So if I ever want to go back and say, hey, I need less tiles, I can reduce the tiling, but everything else stays the same. I still have my grout, I still have my textures, I still have my color separation. I can increase the tiling, and it's all the same stuff. I can rotate it, same thing. I maintain everything that we've done so far. So let's rotate it back. And then let's add a little bit of roughness variation. So good practice is to start separating everything based on what part of our texture it is. So all of this stuff that's related to color, I'm kind of just going to move it off to one side. All of this stuff that's related to height, I'll kind of move it off to one side. And then the normal and the ambient occlusion, same thing. I'll just kind of move them off into their own sides. So let's start cleaning things up here. I'm going to select this bunch of nodes for my height map that we just kind of separated. And there is a button that will just add a frame around it, this one here, with the little graph. So if you press that, I've now got this frame, and if I move the frame, it moves all of these nodes and keeps things super organized. So this frame, we can rename it. This is our height map generation. I'll grab all the nodes up here for our color so far. Hit the same button. This is our color. Small random tidbit. It would do you well to start when you're doing art. Name things with the American spelling of color when you're working typically in this stuff. You've probably seen me do that randomly maybe and wondered why. All of the existing programs that we use, OpenGL, DirectX, etc., 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 industry standard softwares like Maya and Blender, they're all, for the most part, maybe not Blender, built in the US in some capacity. And so when we have these default workflows, a lot of them use things like regular expressions to find the names of things in your files, and they are going to spell color the American way. So typically when I'm working with this stuff, always going to be using the American spelling just to keep things consistent, and because then when we export, it will properly catch the names of our files and things like that. Anyway, that's a small aside. So let's make another one here. I'm just going to frame out the normal map, which might seem silly, but you never know when we're going to add more stuff to this frame. And we make another one for the ambient occlusion, which again, might seem silly, but we are probably going to add more stuff to this frame as well, or use levels to adjust these things later on. Ambient occlusion. Okay, we can adjust the size of the frames a little bit here. And we can change the colors as well. So what colors you use are mostly up to you. It really doesn't matter all that much. Typically though, I like to use some kind of gray for the ambient occlusion, some kind of blue for the normal map, and something pretty punchy for the height map, since that's one of the more important ones. This will be relevant for your work if you're sharing any of these files, and it'll also be relevant because when I go to grade this, it will really help me find the different things and see your organization. This is part of your marks as well, is the organization, since if your graph isn't organized, it will be impossible to understand and read. So let's keep breaking things down bit by bit. We've got a few different maps here, but one big one that we are missing is going to be our roughness map. And that's going to bring a lot more life to this. And we want to do the same thing that we've been doing. We want to start with some kind of base. Luckily for us, we did the hard part of creating these height maps. Granted, these are very not complicated height maps, but we've done the hard part so far. We can use the mask that we made to select our different areas and blend in new values for our roughness. So let's go ahead and grab one for our tiles. We can use this edge detect with just not the grout. And then we can use this for everything else. So let's grab our tile. We'll grab from the bevel, and we'll start our roughness from here because it already has a good mask of the different tiles as well as the grout. So I'll drag our bevel out into an invert. Now we have one for the grout. And then I'll just pull this out and click this little dot node. It basically just ties down our link. So this one here is for the grout roughness base, and then this one is just a link back to the original one, but it keeps it much more organized because it's not all the way back here, it's floating out over here. So now we can take this and separate this into a different section for the roughness. So now it's the same idea as the height map. We're going to blend some base colors in as default roughnesses and then go from there. So we're going to add a uniform color, make this one grayscale because our roughness is a grayscale map. And we'll start with a pretty loose value here. Don't worry too much about the specific numbers. The idea is not to get caught up in the specifics. You want to work in the big picture. So let's use this as our roughness value for the tiles. So that would be this node here we grabbed. Pop this in, pop this in. There's the tiles. Let's see. Now we're going to do the exact same thing, but again, so I can duplicate this, except this time it's the grout. And so we can give the grout a much darker roughness value. A much rougher value. Right. And have these backwards. There we go. Okay. We can add one more blend, this time with an add. And then I'll add our blank spaces together. And we'll end up with a node that has both of our values. So we have our roughness for our tiles and our roughness for our grout. Now, sometimes we want to export these materials as a whole to other programs. And so it's super useful to be able to change these things on the fly. If you've used the base material in Substance Painter before, you've probably seen the options to go down and set a default roughness or things like that. This is how you set that up. So for each node, we can actually create a parameter which is going to allow us to adjust this when the node is exported, when the entire graph is exported. It also allows us to change it a lot easier from the node settings here. So if you just double click anywhere on the background, sorry, not node settings, the graph settings as a whole, you'll see a bunch of stuff here. We can set the physical size and other things like that. You can see the identifier, which in this case is bricks, but we obviously aren't making bricks. And then down here, you'll see we have all of our different parameters that we can change, which right now is just empty. So let's start creating a few parameters to make this material a little bit more usable for our peers. And the first big one is going to be this checker material. It should be flexible. Whoever's using this material should be able to change the number of tiles and the rotation of the tiles. So we can pop in here to the tiling, click, and create a parameter. Expose as graph input. Or you can expose the entire node by left clicking or right clicking on the node and clicking expose parameters. Okay, and it'll ask you which ones you want to expose. We can say we want to expose tiling and rotate 45 degrees. Okay. The other options there are for setting up groups. So if you go back here, we have options to sort these by groups and things like that. For now, we're just kind of leaving them, right? But now when I export this, I'll have the ability to change tiling and rotation, right? By default, these keep the names from their node. But when we actually export this, the node's not going to be there. So we need to provide some kind of context for our artists to use when they're in Unreal using this or whatever else. So this tiling, we can keep the identifier tiling, but the label here we can change from tiling to checker tiling or something with a little bit more detail so that we know what's being rotated and what's tiling. So this same thing, our label rotate 45 degrees. We can say rotate checkers 45 degrees. Okay. And now when we export these have actual context that our artist can use. So let's repeat this for these. These are going to be our roughness bases. So I'm going to hit Control P, expose it, output color, and then the identifier. I'm not going to worry about it. We'll just do it afterwards. Same for this one. Control P, expose it. By default, you can't use the same input identifiers for multiple things. So we can change this one to something else. This is our grout roughness. Grout roughness. Okay. We'll just hop back to our graph settings here and go tweak this again. So output color is actually the tile roughness. So we can change the identifier and the label. Tile roughness. The label can be a plain English title. It's just what shows up in the parameter itself. The identifier should be using some kind of consistent case, be it camel case or whatever else, because this is what it uses in the backend to determine which parameter is which. So grout roughness, but the label can be grout roughness with a capital and a space and proper naming. Great. So we can change all of these from here now, setting defaults, minimum and maximum, and all that good stuff for when we export these to another program like Substance Painter. So let's grab our roughness value here now. And I'll add a new frame and call this one roughness. All right. Same thing as before, we need to open up this parameter. So down here, we'll find roughness, open that up, and then drag our roughness value into the roughness slot here. Good. And now we are actually working with all of our own base maps except for metallic, but we don't really care because there's no metallic values in this material. So instead of creating and opening up a slot for that metallic, I can leave this as it is, set my metallic in here to 0, and it will stay 0 when we actually export this material. I'm going to expand this frame for the roughness because we have a lot more work to do here than just that. Realistically, we have a lot more to do with the height, but we'll worry about that later. We've got a great base for our core big shapes, so now we can start to work on the smaller scale of things and work details into our other shapes. So to get started, in Substance Painter, I've taught you kind of the same thing, build up these big masks, and then we're going to multiply on a bunch of noise to create detail variation, whether it be color variation, roughness variation, etc., etc., etc. We're going to do the exact same thing here. So by default, this roughness, just as it is, way too plain, way too basic, way too boring. Not what we want. So what we want to do is come in, and before we blend it together here, we can just start adding a bunch of variation. So I'm going to move this section down here, probably even further. The roughness and height are what's going to take you the longest by far out of everything. Color maybe third. Ambient occlusion, normal maps, pretty automatic for the most part. So let's create some more space. Let's call on my old good pal Clouds 2. Oh. Sorry, that's not how that works. Spacebar. There we go. Welcome back. So now I can drag this Clouds 2 into a blend, and wouldn't you know it, I'm going to blend this Clouds 2 onto my foreground using a multiply, and we can adjust this value to determine just how much it's going to affect this roughness. So I'm going to multiply it a decent amount. All right, and now we've got some variation. I can also just fly down this mix here, and maybe something like a max lighten is better here since my roughness value by default is so low. If I use a multiply, the clouds will just multiply it darker. If I use a max lighten, it will just take the areas where the clouds are and make them a little bit brighter. If we think about how tiles are, they're probably pretty shiny when you get them, and then they get rougher over time. So our roughness detail should probably work the opposite way, where it makes them less shiny. So I'm gonna use a max lighten here. One thing you can do if you're trying to get through nodes is just pop in to one of these and hammer your arrow keys to go up and down through them, and maybe you'll find something that you weren't expecting that you actually like better. I'm gonna leave it at lighten up. So this is a very small change, but it will make an incredibly big difference when it comes to how good this actually looks, because our values will no longer be so flat. Okay, you can see it in our blend here. That's only going to affect the areas that are tiled, and the grout will remain as grout. The grout, though, is not safe from this. I'm going to run a bevel actually again on this grout, I think, and we'll just see how that kind of looks. There's no guarantee this works, but to create the appearance that this grout is old, I want it to sort of cave in a little bit more. Instead of being like a flat and then out into the tile, it would kind of cave in between the tiles themselves. So we can take this, and then we'll just kind of blend this back on top. To create a little bit more variation here. If you double click a node, it will preview it. I probably should have explained this way earlier. If you double click a node, it'll preview it. But if you click another node once, I can still access all the parameters. So I can see how my bevel is going to affect this future node from here, which is obviously quite useful. Yeah, I don't think this is going to do exactly what I want it to do. We can get close. And then the same thing, I'm going to multiply some noise into this one as well. So blend, we'll find an existing noise, and we'll multiply it all together. Okay, and then we have something that's a little bit more like grout. We can adjust the intensity by changing the opacity. And if we wanted to, we could also create parameters based on these so that in engine we could change how much dirt there is in the grout. So let's blend this new section together now into it as well. And we've got something just a little bit nicer for our roughness channel. The last thing I want to do here is add a second layer of variation. So we've added one layer of variation to our roughness for our tiles themselves. Let's add a second one that sort of also just creates more detail. So we're going to do this blend thing again. A lot of this is just a triangle of blending together a bunch of different separate pieces until we end up at a more final result. So take our clouds, take our blend. I'm going to duplicate the blend, run the previous blend into this blend, and then pick a different noise at a different resolution to use for this section. So we can go around, and we want something that maybe would represent footprints of some sort, where there's a little bit more smearing and a little bit more pattern to the wear and tear. So maybe something like this. It's two directional. Something like this. Okay, now we have a second layer of grunge kind of built on that we can always adjust with the opacity slider here. But it's just creating more and more detail. Okay. There's some other elements of this that are too perfect though. The color on our checkers is pure black and pure white. Not something that's really going to work in the long run. We can do two things about this. One is the gradient map. I'm going to go ahead and adjust it to where our pure black values are not pure black, but more of a dark gray. But something that fits more within the PBR specifics. And then same for the white. We're going to bring this white down. It's going to be a little bit more gray. Okay, there's another new node and section I need to introduce you to, and that is called the flood fill. So a lot of times when you're making nodes like this, you're going to want variation across a bunch of different elements. But how do we actually mask out a bunch of different elements? For example, I want every single one of these tiles to have a slight amount of color variation on them. Not every single one should be the exact same white value. Some of them maybe are a little bit more worn down than others. So if we type in flood fill, what we're going to get is a masking node that isolates basically black and white islands in our texture. On its own, we can't actually do anything with this flood fill, but what we can do is pump this into a bunch of different nodes that use this data. So the ones that are going to be most useful to you are flood fill to color, flood fill to gradient, flood fill to grayscale, or flood fill to random color or random grayscale. In this case, I'm going to flood fill to random grayscale. And you can see now that I've got a random level between 0 and 1 for all of my different tiles. Why is this useful? A few reasons. Well, one, we could always take this and multiply it back into our height map so that all the tiles are not perfectly level. Some of them might be a little bit sunken more than others, right? For something like tiles, this is a little bit less relevant, but if we were working on something like bricks, we would want a ton of that variation. Or if we were working on tiles that have been smashed into the ground and were a little bit more rough and tough. I'll probably go back and do a little bit more wear on these if we have time. It's 9:30, we're halfway done, so we should probably have that time. In this flood fill to random grayscale though, there is one kind of issue, being that the values will always kind of jump in between 1 and 0, and you don't really have any control over that. So you can see here, I have a tile that actually just went to pure 0. So if I try to multiply this pure 0 onto some other colors, it's just going to come out black, which isn't really what we want. So, as you could probably surmise by now, That means we have to blend it together with our color and use levels, or it's the opacity, to adjust the intensity of it. The other thing you'll see is this is grayscale. So if we try to just by default blend this in, it's going to freak out because now we have one color input and one grayscale input. So we use that trick that I talked about earlier, where we just plug this into a gradient map and it turns our black and white data into color data. So if I set this to multiply, I have them backwards. If I set this to multiply, I can change the value ever so slightly to adjust the values of these tiles. So let's take this and blend this in now. And it's a subtle change, but it is fairly noticeable, especially if we tile this pattern just a bunch of times. So let's add these nodes to our color here as well. Trying to stay organized where you can. Since we're in the color section, we can also add a couple more parameters. So we have the color here for the tiles, the base color, and the base color. Well, this is the base color for the, yeah, for the tiles. Okay. So earlier I separated these into the two sections. This is why. Because the flood fill is only going to work on the white islands, this flood fill is only affecting half of the tiles currently, right? I want it to affect all of the tiles. So we can separate it to create different variations. We could also just use the original one here, but doing it this way, we probably are going to need more color variation on the black tiles than we do on the white tiles. So I thought I'd separate it earlier. This is because if we try to multiply values into black, they're typically not going to go as far as if we multiply them into white. So having them separate just lets us have more control. So I'm going to do this again, just add a flood fill, this time for the opposite tiles. Do another flood fill to random. Gradient map this one. We can run another blend to do our variation on the other ones. So now all of our tiles have some level of color variation applied to them. Going back to our roughness here, I think we could adjust the values a little bit more. So where we blend our grunge in, I'm just going to increase the amount of grunge. Okay. Pull this all together. Is everybody fairly good so far? Not too confused? All right. So I'm just reorganizing a little bit to keep track of everything before we jump into the next part. So we did work on our height map and we created a great base for things. That doesn't mean we can't go back and change things later. This is a pretty clean material, right? If we wanted to say that this was good, we could save this right now and call it quits and say, hey, this is our clean base tile. But like I said, we want variations of these materials. We don't just want the one typically, right? This is great for texturing the entire floor, no problem. But if we wanted to use vertex blending in any good capacity when we get back into Engine, we want to create a maybe dirty version of this tile, a destroyed version of this tile set that we can blend in seamlessly between the two. And because we need them to blend in together, a great starting point for our next one is to just use this exact same graph and start to add more detail to it. So I'm going to go ahead and save this, and I'll rename this from bricks to something else. Checkered tiles. Okay. I'm going to right click on my package and hit compute outputs. And then we'll put this in Engine for now, just to get an idea of how everything is looking. So if I go down here to textures, we just make a new folder for our checkered tile. And we'll import our maps there. So I'm going to right click on checkered tiles, scroll down to export outputs as bitmaps. And you can see, because we set up earlier those output specific parameters for where each one of these needs to go, it's going to give them the proper name that we gave them, and then it should give them the proper color space, assuming we set that up as well. So normal map we leave as raw, but roughness is linear, height is linear, metallic, etc. For destination, just going to go straight into Unreal. PNG, and then we have this exact same sort of setup here with the regular expression for the name of the graph and then the name of the map. I'm going to just click all of them for now and press this little button here. If your computer can handle it, I'd recommend doing this. It just makes life a lot easier. There's a button here called automatic export when outputs change. And what this does is, as long as we've exported this to the proper spot in our engine, every time we make a change in Designer, it's just going to re-export everything. So if I press this, click export, okay, and hit close, we'll pop into Engine and make a new material. I'm not worrying about, do you guys know what master materials are? Is that like a familiar? Not really? Okay, we'll learn about them next week, so I'm not going to worry about them right now. I'll just make a new default material and we'll go from there. So I'll call this one checkered floor. And then we'll do all the same things we've kind of been doing. I need to add some samplers. And just drag and drop my textures in here. Okay, and we can start plugging everything in where it belongs. So base color. This is the AO. This one is the height, which you can ignore for now. This one is the metallic. And this is our roughness. And our normal map. Everything is going to look pretty wonky, I think, by default here, because we didn't tell the game that this is a normal map. Oh, it already figured it out. So now we can theoretically just take our material and start slapping it onto things. This is color, not linear. Okay. By default, I just dropped it onto this giant plane that we can shrink down to match our scene size. Let's go 40 by 40. That's a little bit big, 20 by 20. This is just a default Unreal object. But let's say this is what we're working with. If I was to hop back into Designer now, and because we checked off that automatic export, if I change this color now for the tiles to like red, or the grout, sorry, it will automatically do all the exporting and update right in Engine. So I don't need to do any more exporting or anything like that. We have automatic exporting turned on. It is more computationally expensive, but ideally what you would do is have two monitors set up like this. Obviously this isn't two monitors, but it's the same idea. And then any changes we want to make, we can see happen live in the engine. So if I go back here to our tiling, and we just bank this up to a lot higher than it is, 16 let's say, I'll see that change, and we can see how the tiling looks when we're actually in Engine. So this is what the tiling looks like in Engine now. Okay, and we have our checkered tiling material. If I want to change any of the edge widths or anything, I could change that here as well. Change the bevel, etc. It'll all reflect itself automatically in Unreal. Okay. Yep, Aiden. Because I'm changing this as like the parameter for the texture itself, there is no resolution change because it's still exporting at 1024. So the resolution is staying the same, just the amount of tiles and the amount of resolution that each tile is getting is decreasing. So it is typically going to be a little bit better to sort of keep this smaller form factor and then in Engine scale it up and tile it up. If I was to break this up into like 10 different pieces, 1 by 1 meter, instead of just one giant piece of land like this, then it would keep that same 1024 per 1 meter by 1 meter space. Onto a what, sir? Onto organic shape? Mm-hmm. Well, it would just use the UVs. It's just using the UVs of all these other objects. So if I drag it onto something like this, it's whatever the UVs are. So it would tile, lengthwise across. You can create what's called triplanar materials, where it would take this material and just apply it broad scale. But that's not something we're really going to cover. It's more for large outdoor environments. So we have this in here with a very large size tile. Because the texture is going to cover the entire tile, the tiling isn't quite right, but we can always adjust that later. I'm just more interested in seeing how it looks in Engine as far as the color, the roughness, and everything else. It's 9:47. I don't want to absolutely bore you, so probably what we'll do here is take a short little break. We'll come back to it at 10:05 or so, and then I'll knock out adding a second version of this with wobbly tiles and cracks and damage and that kind of thing that we can use for variation between the two texture sets. Okay, so we'll take a short break here and then come back to it. Ashley?
Can you come here and help me with that?
All right. I'll pick up the recording here and we'll kind of keep going. So we'll just add a bunch of extra damage, which is going to be a lot more getting into the nitty gritty. And then we'll learn how to export these into Painter for use in other kind of texturing. So this is basically, we're building up one of those base materials in Painter with those parameters we've been exposing. So let's start building up an additional kind of layer to this. So this is fine as a base, but what really makes good materials is creating that storied element. Whether it's the little bits of grass that are growing in between your bricks or the cracks and damage that comes with tiles in a kitchen where things probably get dropped on them. So to get started off, there's a few things you could do kind of at this point. I'm going to build the damage right on top, and we can use parameters to control the level of damage as opposed to make an entire separate material. This just keeps it all kind of together in the same vein. So we're going to work backwards again, starting with the big shapes and working into our small shapes. So I'm going to start with some kind of noise that we're going to turn into cracks that we can use later. So I'll find the noises that we have available to us. One that works pretty well for cracks is going to be this cells 2 or cells 1. Cells 1 probably better for realistic stuff. Cells 2 very Wind Waker-esque. I'll use cells 1 here, and a big part of being good at Substance Designer is figuring out, hey, where can I take one of these maps and use it in some other way? As you practice, you'll learn a bunch of these tips and tricks. I can promise you that none of these things I'm doing, it's the first time I'm doing it. I'm not just sitting here going, okay, yeah, this cells 1, I know. I'm seeing 40 steps into the future, and this will be a great one to use for cracks and edge damage. That's just something that you learn from doing it a bunch. So we can use an edge detect here to filter out a lot of this. We'll come in here and just decrease or increase our values until we get something a little bit more like what we're looking for. This is actually turning out terribly, so maybe we'll pick a different noise instead. This looks like something we could definitely use for chips and little cracks and things like that, so maybe I'll keep this off to the side for now. What else can we use here? I'll pop this back out, but use a histogram range instead. A levels. To invert everything. And then multiply this together with some kind of grunge just to break up where our issues are. This is also just too big as a whole, so we can kind of break this down to get much larger areas. Okay, we can always change this. Kind of going back and forth, figuring out what looks best. Actually, this probably does look much better. And we'll kind of ignore this for now. I'm going to flood fill this and use this as kind of cracks. We can flood fill to a random gradient. and adjust the angle variation. So now we have a bunch of different chips that are all kind of rotated and slanted up and down in different directions, and also these cracks in between. So I might adjust this just to kind of lessen the amount of breakage. But this is damage that we can then take and kind of multiply on top of our height map. As if things are all chipped up and broken. So let's take this down here. Run another blend. We're just going to blend this on top with some low value. It's not super specific or anything at the moment, but it might just help break these tiles up. We'll shrink these down. Something like this, maybe. Okay. I'm going to repeat this with the existing tiles to give them a slant that this other slant will kind of be multiplied on top of to give more variation. So same thing, flood fill the gradient. Rotate this angle a bunch just to get some sort of random directions that these tiles are rotating in. And blend it all together once more. Then we can punch this into our levels. So now we're starting to see sort of chips and cracks and wear in all of our tiles. All right. And we can adjust that by adjusting the opacity of these blends. So we can use this opacity as our cracks slider when we make this into parameters. We might just hop through these a little bit first to see if we find anything we like a little bit better. All right. This gets passed back into our levels, and we can kind of add this to our height. You can also take these little chip bits that we kind of made earlier, or we can create some new ones using the same kind of principles here. I'm going to use just the levels to create much sharper details here. Move this up. That might be a little bit much, so we can pick a different grunge. And the idea here is just building up that detail and that damage bit by bit while constantly thinking about how each element is going to be masked out later. This is much more appropriate for what we're doing, so I'm just going to use this from the get-go. Something like that looks good. The issue is if I take these and I just subtract them from my map as they are, they're going to be extremely sharp, which sometimes might be what you want, but we can also add a, what's it called? High blur. It's a blur HQ grayscale. So this is a high quality blur, it's lossless, that we can use to just give these a little bit of roundness and a little bit of blending so that when we multiply these into our height map, it's not quite as sharp. So we'll make a little bit of room, add another blend to build up layer by layer. So put these in the foreground, our original in the background. and we will subtract these bits because we want them to be cut out from the tiles. Okay, and this slider will control how deep these chips are. If we want to make the cracks bigger, we can just increase the scale of this to give us more variation. And I'm going to allow a little bit more range now that we've added a little bit more to our tiles here. I want to add more of the range to our levels node to just allow these elements to stand out more. You can see by increasing them, now they've started to get caught by the AO map here. And so we're getting AO in between all of the tiles as well as these little details getting AO in here. So I'm going to reduce the subtract on these because they are just a little bit too deep for my liking. And I want to run a blur on some of this stuff as well because these are a little bit too sharp for my liking as well. So let's run a blur. We can't blur it too much because this flood fill is depending on these gaps in between, and if we do a blur here, we are cutting off some of that. So you can see now my flood fill is broken because the blur is linking all of those islands together. If we blur this by a very, very small amount, just enough so that it's not quite so jagged, it shouldn't affect our flood fill too badly. So that's still not good enough. We can increase the gap between our cells just to kind of help with the flood fill. Maybe something more like that. At this point, I'm going to go up here and bump my parent size to 2K just to get a better idea of what's going on here. And I want to take this kind of chipped damage bit that we created, and just to help kind of sell everything better, I'm going to filter this into our roughness and color variation values as well. So we'll add another pass down here. Drag this up to our color, into a new blend. Lots of blending. You're going to have to get used to it. Make sure we turn that black and white map into a color map with the gradient. And now we can very loosely multiply these two together. We did this backwards. So this one goes up here, and this one goes down here. Just a bit, because you imagine the color would change over time if this has been broken for a while, let's say. Okay. The next big thing that's standing out to me is all of my cracks are the same depth here. And so it's looking a little bit funky because you can see all the different places evenly. We are going to need this in some capacity just because of, again, the way the flood fill works, but we can start to knock down some of these elements in here by multiplying another set of noises onto it. Something to note is that for every node you add, you are adding more compute power. So a good way to save on resources is to try and reuse nodes as much as possible. It does save on compute times, and also it really helps you when you're exporting this, because if I make change to one node, let's say I increase the tiling of this. Well, I probably might want to run some function that also tells it to increase the tiling of my cracks, because if I increase just the tiling of the checkers, if I bump this up, my cracks are staying the same size, which isn't what would actually happen. So we can leave that there. That requires a little bit more math and using those math nodes to input different scalar values into these. I'm not going to worry about that too much, but these values you can inherit from other nodes as well. Let's see. Yeah, so here we go. For scale, I can use existing graph input, and now it'll match 1 to 1. So if I increase the tiling, they'll move together. Good for when you put it in another program and you want to use it. A little bit funky for me because we're not using the default size. We could take this and we could say multiply it by 2. It's a constant integer. And this is our output. That's all the math stuff I was talking about earlier with the different graphs and everything. If you are so inclined, probably look that up yourself. I don't think it's worth showing everybody that in detail because most of you will not be making use of it. But that's how it generally works. So let me just reset this and we'll keep going. .5, I think. No. I don't remember what I had this to. Something like 10. I'll just keep going. Okay. So now we've got some cracks and things like that in there. We can add some dirt and other things as well. So just like in Substance Painter, how we can kind of use the ambient occlusion as a mask for dirt, we can do the same thing here. We already created that height, and that's going to give us this detailed ambient occlusion mask. And this is typically where our dirt is going to find itself. It would kind of find itself sneaking into areas like this, right? Looks like a bunch of destroyed kind of checkered tiles. So I'm going to take this ambient occlusion node and pull it back here and use this to start blending in some dirt. So same as Substance Painter, there's a lot of existing nodes that we can use for dirt. I'll grab one of those just to keep it simple. And we'll be using the ambient occlusion to sort of blend this all together. So I want to first invert the ambient occlusion because the areas that are black here on the ambient occlusion is where the dirt's going to get. So if we invert it, those areas are now white. I'm going to multiply this by some kind of noise because we don't want it to be built up evenly throughout. I'm going to multiply all of this again by some other kind of noise to break up the areas so the dirt isn't so uniform. So let's take this dirt and increase the scale just a bit. And now I need a much larger noise. Let's see. Perlin is something that's pretty good for creating nice, flush blending between different heights. Let's see. Perlin. There it is. Perlin noise, pretty derived from nature, works pretty well when dealing with nature. We get nice even blending between it all, and we can multiply this in as well, or use subtract or some other system to sort of just knock down where this dirt is found, because we don't want it found literally everywhere, right? So there we go. You see the difference here is the dirt is incredibly even throughout everywhere, and now with the Perlin noise, we have a little bit of control over some variation in this dirt. We want this to be pretty subtle, because if it's not subtle, then it will be very obvious when it tiles. So let's take this now And with this dirt mask, we can do two things. We can multiply it into the roughness, because dirt would obviously be pretty rough. And we can multiply it into the color, because dirt would also obviously be probably not the same color as these tiles. So it's all about making these masks. So let's start with the color. A gradient map. This is where we'll actually use the gradient map to create color instead of just using it to convert. And then we can go ahead and pick some values that would make this sort of match dirt. Okay, and then we can blend it together with our existing stuff. I'm going to take the original value and pop that into the opacity. And then that way we don't have to worry about finding a blend mode that works. The dirt will just properly overlay on top with a copy. And we can just use this to control the intensity of it. And this is our new base color. It's not super intense, so we can kind of increase that. Find the map. Sort of punch that color in a little bit harsher. And now our dirt is a little bit more pronounced here. It's not showing through really well on the material here, partially probably because the roughness value hasn't changed. We can also check in Engine to see if it's computing any better there. Oops, not there. I changed the name of the graph, so that's why it's freaking out there and making me rechange everything. Which means we will also have to adjust this. I believe it's these ones. And we'll plop all these in. Normal, AO, roughness. Okay, there we go. So you can see this in game. The dirt does show through a lot more than it does in the actual render. And the cracks are a little bit obvious, so we could always go back and tweak that. So I'll blend, once again, some other kind of noise on top of this with a blur, just to make this all a bit more uniform. And kind of bridge some of these areas between. Okay, back to the dirt here. I'm going to overlay a second layer of dirt by shockingly blending it in. So we have the AO dirt covered, and then now this will be the dirt that's just sort of like a natural buildup dirt. So just like texturing in Substance Painter, we're thinking about all of the different ways this might have been interacted with. How long has it been sitting here? How long has this dirt and grunge been allowed to build up? That all goes a long way. So let's blend this together with this as our foreground and this is our background, and then we'll add. Cool. And we'll blend this over. Cool. So let's say we're happy with our checkered material now. Normally what you would do at this stage is go through and add the rest of your parameters anywhere you feel the need to. So it would be good in this case to have a parameter somewhere along the lines of here to control the dirt. So this controls the blending of the dirt. You could have a slider in here that you add that changes the actual amount of dirt, etc., etc., etc. The reason we need to add those is basically just to have it export properly into Painter. But as far as putting it in Engine, this is pretty much where we're at. This would require a bit more work to look pretty proper. The cracks are very stylized compared to everything else, but for the sake of demonstration, I think you guys mostly get the point, and I don't want to hold you here forever. So let's actually put this now into Substance Painter. You might have seen me kind of navigating here earlier, but you're going to want to try and find your Substance Painter install directory. It's simply going to be in Documents, and then under one of these systems, depending on when you downloaded it. I downloaded it from Adobe, so I have Adobe Substance 3D Painter in my Documents folder, and this is where all of your imports go. So here we've got Assets, and inside there you'll find Materials. So you're going to want to open this folder up. So by default, you'll just see a README, and it kind of pops up and it says here to put your SBAR and image files if you're going to use them as base materials. Image files can be used as base materials that are unchanging, they're static. That means you can't change the parameters. We don't want to use image materials because we just spent all this time creating these nice parameters that we can change in Substance Painter. So I'm going to take my tiling texture here. Going to click on my package and press Publish SBAR File. A little thing is going to come up with a preview of what your material is going to show up like in Substance Painter. And then it's going to ask you where you want to put this. So we're just going to navigate to that folder, Documents, Adobe, Substance 3D Painter, Assets, Materials. Okay. And here it's checkered tiles.sbar, name it whatever you'd like, and save. Okay. The color map is breaking, but that's fine. It's still importing that data. So if I publish this now and open Substance Painter, that's the old one we made. Within Substance Painter, under the base materials slot, you'll now find your material. And remember, we talked about earlier when we started with Substance Painter that this little dot thing includes randomness, means that it's a modifiable base material. Well, you've just now created your own modifiable base material, the same way that all of the existing base materials were also created. These were actually just created by artists that work at Substance in Designer. and we plop it on. We get all the channels we're used to. Color is a little bit messed up, but that's fine. If we press the color button, it will show up as intended. And now we have our checkered material on here. Even further and even better, down here is all the parameters that we spent all that time exporting and making sure that we name properly. So now I can adjust these here in my base material to change how it works in Substance. So I can change my tiling, I can change the default roughness, I can change the roughness of the grout as well, right? And I can decide if they want to be rotated or not. I could definitely go further with all this, add parameters for the bevel, add parameters for whatever else you would like, and then you can start building a smart material up on top of this. Why is this good? Well, let's take something that we already made and use that as an example. I lied to you big time about these trim sheets. Ish. But we needed to know more about Substance Designer before we could make them in some kind of standard fashion. Something like this wood material, I'm gonna need wood in other parts of my scene, and I'm literally gonna need the same wood, more or less, for the top, but just made in that Substance Designer folder. So material. So to match the wood throughout all the project, what I would do if I was building this up properly is make that wood in Substance Designer first, and then you can import that wood you've made into Painter and use it to texture your individual objects like your trim sheet. But this way everything remains consistent throughout your scene. We taught it to you this way because you needed to understand materials first as a whole before you kind of dive into this designer stuff, and because it's not necessary, that's just one way to do things. But if you're stuck trying to make all your materials look the same, this is a huge component of that, because instead of dropping in this default American cherry wood when I was texturing these, I could have dropped in my game specific or project specific Substance Designer base material wood that I made originally to keep everything the same. Okay, so that's pretty much it for all of this stuff. I don't know if there are any questions or anything like that. You'll notice my stuff is actually broken here. It's the old checkered material that's going on. This is just a issue with its linking. So I'm just going to delete this. Open a new folder or file. You don't have to copy this part. It was just because I already had Substance Painter open. And now if I export this, that metadata will be gone. And this should link properly. So publish. Publish. Sample. Then we should have it pop up. Or not. It will pop up here when you do that. The other option, I guess, because it's freaking out on me, is to just actually import it the old-fashioned way. Import resources, find your resource. And import that as the base material. And there you go. Now we have our checkered material in here, ready to go to texture any asset that we want. Any questions about any of that stuff? This program is going to be super useful. You are going to have to learn it both for your environments for GDW, my final project, and assignment 2. So do spend some extra time getting used to it. I would expect the assignment 2 submissions to at least be on this level of quality. Especially considering you're more than welcome to use video tutorials to help you create your stuff and just kind of follow along and copy those. Your materials should all be in very good shape. The last bit is actually rendering these. 2 ways to do it. One is going to be rendering it inside this viewport here. The other is to take it to something like Painter and use the iRay rendering once you've just dragged it and dropped it onto a preview material. This obviously being much nicer for me to look at than a screenshot, right? So same thing, try to maintain professionalism when you're submitting these, just like everything else. I'll end the recording there, and then I'll help anybody if they have any more questions.